in my today's session on Conductors and Dielectrics. Myself Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering in Institute of Aeronautical Engineering, Hyderabad. So today I am here to tell you about the conductors and dielectrics. The main course outcome of this topic is to tell about the different features of the conductors and dielectric system. So first we will go polarization. The first thing when we are discussing about this, the first term comes into our mind is polarization. What do you mean by the polarization? So the polarization is also called the wave polarization. Then another name of the polarization is also known as the wave polarization, is an expression of orientation of the lines of electric flux in an electromagnetic field. So this is the main thing, it is in the electromagnetic field. So polarization, the another name is the wave polarization, is an expression. It is not a physical thing, it is an expression of orientation of the electric lines of flux in an electromagnetic field. Polarization can be constant, that is the particular orientation at all direction, or it can rotate with the every cycle. So polarization can be two types. Either it can be constant. Constant means it is constant existing in a particular orientation. Like if we are going for any metal, the polarization are the constant, but sometimes the polarization also rotate with the rotate of each cycle. So polarization is also defined as the electric dipole per unit volume. The polarization can also known as the dipole moment per unit volume. So here we can get the another important term, dipole moment. What is the meaning of dipole moment? If two charges of equal quantity. What is dipole moment? Dipole moment means if two charges, say one is plus q, another one is the minus q, of the same magnitudes but opposite in polarity, and they are connected through a line, there is a moment is there. This is called the dipole moment, and dipole moment per unit volume is also known as the polarization. So let A is the cross section of the dielectric and L is the distance between them. This L is the distance between them. So what is the polarization? Polarization is dipole moment per unit volume. Polarization is, as we defined, dipole moment per unit volume. So we can know dipole moment is equal to Q into L, and what is the volume? Volume is the cross sectional area into the length. So we got the value Q into A. What is Q into A in electromagnetic field? We have discussed earlier many times. Charge per unit area is known as the surface charge density. So mathematically we can tell that the dipole moment is equal to the surface charge density. According to the definition or according to the physics, dipole moment has no relation with the surface charge density. But mathematically we can write that the polarization is equal to the surface charge density, whose unit is coulomb per meter square. So as I told, the polarization is numerically or mathematically we can tell that mathematically it is equal to the surface charge density. So this is only mathematically, but according to the physics there is no relation between the polarization and surface charge density. Next, so we have discussed in the previous slide one important term, that the dipole moment. So next questions which will come in our mind, what is dipole moment and what is the necessity of dipole moment? So now we will discuss the dipole moment. When there is a two charges of equal quantity or equal magnitudes but opposite in direction, what will happen? First I will write it, then I will show. So say one charge is plus q, another charge is minus q, and they are connected in a line of L. What will happen? The positive charge tries to go towards the negative charge, and negative charge will tries to go towards the positive charge. And as a result, what will happen? The charge will, the charge Cg will change. The positive charge will align to the negative charge, and negative charge will align to the positive charge, and as a result there will be a moment. This moment is known as the dipole moment. So if we go for the definition, so two opposite charges plus q and minus q, if they are separated by some distance d, forms the electric dipole. Plus q and minus q means both the charges are of equal magnitudes but opposite in direction. You can see this is the plus q charge and minus q charge, and there is some distance d between them. So the distance traveled by the point charge is defined as the dipole moment, or the product of charge with the distance is called the dipole moment. Dipole moment is equal to P is equal to Q into D, the magnitude of the charge and the distance between them. So now we will discuss about the properties of the dipole moment. So the first property is the electric dipole moment is a measure of the separation of positive and negative electrical charges within them. So the measure of the system's overall polarity. So what is dipole moment? According to the definition, in the dipole moment, the equal or same magnitudes of the positive charge and negative charge will be there. Instead of that, if there are any extra charge, if this is a positive, more positive charge is there, the total system will be the positive. If the negative charge amount is more, we will tell the system is of the negative polarity. So the electric dipole moment is a measure of separation of positive and negative electrical charges within the system. That is, it is the measure of the overall polarity. And as we discussed earlier that the polarization is equal to Q into D according to the definition. So the SI unit of the electrical dipole moment is the Coulomb meter, or C into M. The major effect of the electric field E on the dielectric is the creation of the dipole moments that align themselves in the direction of E. So if we keep the charges in an electrical field E, the dipole moment, the moment of the these dipoles will be such that they will align themselves in the direction of the electromagnetic field E. This type of dielectrics are said to be nonpolar. So these are the nonpolar dielectric. What are the example of nonpolar dielectric? Hydrogen, oxygen, nitrogen are and the rare gases. Rare gases means there are 6 rare gases: helium, neon, argon, krypton, xenon and radon. So these gases, or all the gases, has the inherent the dipole moment property. If we give in the dipole moment, if we keep this gases in an electrical field, they will change their directions according to the alignment of the electrical field. That's why these are known as the non-polar. Non-polar dielectric do not possess dipole until the applications of the electric field have been given. So when there is any gas, if we keep it in a normal condition, there should be no polarization. But if we keep these gases or this nonpolar elements in an electric field, they will align themselves in the directions of the electric field given. Other types of molecules like water, like the compound material like water H2O, sulfur dioxide SO2O, hydrochloric acid HCl, which is in where one is the metal or the hydrogen, another one is the non-metal. If they have an inherent dipole moment, and they will align themselves such a way that they are always in a polar direction. When the electric field E is applied to the polar molecule, the dipole experiences a torque tending to align them the dipole moment parallel to E. So what does it mean? Say we are giving the EMF E, field intensity E in this direction, and we have one water molecule whose direction is this. So this is the direction of water molecule, and E is the direction of the field. Now what will happen? It will feel some torque so that it can align it parallel to the E. So this is the one important property of the polar molecules. Polar molecules are always the compound molecules are there. So this is the main properties of the dipole moment, and dipole moment is the unit is the coulomb meter. Dipole moment is two types, non-polar and polar. What is non-polar? Non-polar means which align which shows no dipole moment in the normal conditions, but whenever we are giving any EMF, what will happen? It will align themselves in accordance or in the direction of field intensity. Similarly, if polar means they have some inherent polarization. They have some inherent polarization. Whenever we are giving the intensity to them, if we give any field to them, they will tend to align themselves parallel to the E, and it will create some torque. So these are the dipole moment properties. So now we will discuss about what is the torque. So we have discussed about the polar molecules exhibit some torque in the case of the electric field. What is the value of the electrical torque for the dipole moment? So you can see here there are two charges plus Q and minus Q, which are aligned to the electric field intensity E at an angle theta. So this dipole moment will tend itself to be parallel to the E. So the plus Q will, as we know, if any charge is in the electrical field, it will experience some force. And what is the value of the force? The plus Q will feel some force of the E into Q. Similarly, minus Q will also feel some force of minus E into Q. So what will be the total force? Total force will be F1 plus F2 is equal to EQ minus EQ is equal to 0. But the force experienced by the plus Q, it tend to accelerate in the direction of E, and minus Q is in the opposite direction of E. So the plus Q will tend to align itself in such a direction that it will experience some oscillatory force. Similarly, minus Q also tries to tend itself in the direction of minus Q, and it will also feel some oscillation, and as a result it will feel some force. So if T is the magnitude of the F and what is the value of the torque? The magnitude of the force into perpendicular distance from their line of action. So this is what is the force value? E into Q. Magnitude wise both are same and it is EQ. If the distance is R, so it is 2R sin theta. 2R sin theta. So what is torque? Torque is equal to Q into 2R. Q into 2R is equal to polarization PE sin theta. So what is R? R is the distance of this. This is the R from the middle point to Q. So we got this equation torque due to the electric dipole. The value of the torque of the electric dipole is T is equal to PE sin theta. Next we will move to the dielectric. Now important topic is dielectric. Discuss about the permittivity. First we will discuss when we are discussing about the permittivity of the medium. So what is permittivity? The ability of a substance or medium to store electrical energy in an electrical field. So this is known as the permittivity of the medium. Generally the dielectric things will show the permittivity of the medium. The ability of a substance or medium to store electrical energy in an electric field. So permittivity is basically two types. One is known as the absolute permittivity. Another one is known as the relative permittivity. What do you mean by absolute permittivity? Absolute permittivity means the permittivity of any medium with respect to the vacuum or the air. We can write it by epsilon 0 and its value is 8.854 into 10 to the power minus 12. So epsilon absolute permittivity is the property of the permittivity to store the energy in an electrical field. What is relative permittivity? Relative permittivity means the permittivity of any medium with respect to the air or vacuum, and we write it by epsilon r. And what is the permittivity? Permittivity epsilon 0 is equal to epsilon naught into epsilon r. So this is known as the permittivity of the medium. Next is the dielectric constant. What is the dielectric constant? Dielectric constant is defined as the ratio of the capacitance of the capacitor with the dielectric to the capacitance of the capacitor without dielectric. So what does it mean? Say we have two capacitors, plus Q and minus Q, two parallel plate capacitor, and in between of these two parallel capacitor there is nothing. This is a blank. Now if we give some dielectric in between them, what will happen? This will have that epsilon r is their relative permittivity. So dielectric constant is the capacitance of the capacitor with dielectric to the capacitor of the capacitance without dielectric. Or we can write the ratio of the permittivity of a substance to the permittivity of the free space. So dielectric constant is equal to permittivity of the substance by permittivity of the free space, or we can write it by the relative permittivity. As this is the ratio of two like entities, it is unitless or dimensionless quantity. So as this is the epsilon r is equal to epsilon by epsilon naught, so we can tell it is an unitless or dimensionless quantity. So this is the dielectric constant. When we are discussing of the dielectric constant, another term comes into our mind, that is the electric susceptibility. What is the meaning of electric susceptibility? In electricity, the electrical susceptibility is also some unitless or dimensionless quantity. This is a proportionality constant which indicates the degree of polarization of a dielectric material in response to an applied electric field. So what is the meaning? That if we give the electric field to any dipole moment, it will check how many molecules will align themselves in the direction of the electric field, the degree of polarization. So the degree of polarization to the electric field intensity created between two charges. So P is directly proportional to the E. And so if we change the proportionality constant, we get P equals to Ke into E. And what is Ke? Ke is nothing but the ratio of P by E, polarization by electric field intensity. And this is known as the electric susceptibility. So electric susceptibility is a dimensionless proportionality constant. So what is the relation between the dielectric constant and the electric susceptibility? So already we have discussed from the previous section that when we are giving the electric field to anything, we know that D, the electric field density, is equal to epsilon E according to the Gauss law. Now, if there is some polarization is there, then D is changed to epsilon E into P. Now, from the linear equations of the E and P, we got just before one. So, we got the relation P is directly proportional to the E. Or we can write P is equal to xi epsilon into E, where xi into epsilon is equal to Pe is equal to susceptibility. So if we put the value of D here, we got D is equal to epsilon E plus epsilon into E. So if we take the constant epsilon, we got 1 plus xi into E. And what is D? D is nothing but the epsilon into E. Epsilon naught into E, where epsilon naught is nothing but the permittivity of the free space. So we can write epsilon naught is equal to epsilon 1 plus xi into E. And if it is the air, we can write epsilon r is equal to 1 plus zeta. So this is the relation we got, epsilon r is equal to xi plus 1. So this is the relation between the dielectric and electric susceptibility. Next important topic is the define the conductor. What is the meaning of the conductor? So in simple terms, an electrical conductor is defined as a material that allows electricity to flow through it. What is the electric conductor? In simple terms, an electrical conductor is defined as material that allow the electricity to flow through them easily. So the property of the conductor that allow them to conduct electricity is known as the conductivity. The conductivity means the property of the conductor which allows them to start the flow of electrons in anything. So the conductivity is just the opposite of the resistivity. So what is resistivity? Resistivity is rho L by A. So what will be the value of the conductivity? Conductivity will be A by rho L and its unit is mho meter. So this is known as the conductivity, the property of the conductor that allow them to conduct the electricity. The flow of the electron in a conductor is known as the electrical current. So what will happen in the conductor? If this is a conductor, whenever we keep it in a field or we are giving some potential to it, there are some free electrons which will start to move, which will try to align themselves in the directions of the of the electric field, and there is a flow of electrons because proton cannot flow. Positive charge means lack of electrons and negative charge means more of electrons. So if lack of electrons means proton is there and it cannot flow. So whenever we are giving any charge, the free electrons will start to flow, and the current direction is always in the opposite of the flow of electrons. This is the thing. The current direction is always in the opposite of the flow of electrons. So many metals are good conductors of electricity. That's why the parts of the appliances that need to pass electricity are made of metals. In our home appliances, where like the holder of a bulb to any small appliances, where we need to flow some electricity, it should be made of metal, a nichromite, whatever, it should be made of metal because metal is a very good conductor of the electricity. And the plastic coverings the surrounds an electric conductor is known as the insulator. And like you have an electrical wire, so it is it is made of copper. Copper is a very good metal, very good conductor of electricity. Now to prevent us from the electric shock, we give some plastic covering. This plastic is generally known as the PVC, polyvinyl chloride. Polyvinyl chloride. So this is the PVC is given to prevent us from the shock. So this is the and this is behaves like an insulator. What is insulator? Which opposes the flow of electricity. So what are the properties of the conductor? So as we know, what is the first? The conductor always allows the movement of electrons and ions in them. It always allows the movement of electrons and ions in them. And the flow of electrons is known as the electricity. This is the one important point. The electric field of a conductor is zero, allowing to flow within them. There is no stored energy in the conductor. Electric field of a conductor itself is zero. The charge as electric field is zero, and we know D is equal to epsilon into E. So the charge density of the conductor is also zero. If E is equal to 0, then D should be equals to 0. Only on the surface of the conductor free charges exist. This is a very important property of the of a conductor. In the conductor, the charges only stay on the outside of the surface. Inside of the surface there is no charge. No charge exists inside the conductor. So that's why the inducting property of a conductor is always on the outside of it. All points of the conductors are of the same are at the same potential. This is also another very important property of the conductors. All points of the conductors are at the same potential. We cannot change the potential of the conductors. That's why the current flows smoothly in a conductor. Many metals as I discussed earlier also, this is the another important point. Many metals are good conductors of electricity like copper, iron. So these metals are very silver. These are the very good conductors of electricity. That's why the reason of the parts of the appliances are need to pass the electricity are made of metal. The plastic covering that surrounds the electrical energy, the plastic covering means again the PVC, surrounds an electric conductor is known as the insulator. What is the insulator? Insulator means which opposes the flow of the electrons. So it prevents us from getting the electric shock. So what are the property? First of all, the conductor always allows the flow of ions or the free electrons, and the electricity flow is always in the opposite direction of the conductor. The electrical field of a conductor is zero, allowing electrons to flow within them. The charge density of a conductor is zero. As field is zero in a conductor, then the charge is always zero. What is the fourth point? The fourth point is all points of a conductor are of the same potential. Fifth important point is the charge always lie on the outer surface of the conductor. Inside the inner surface of the conductor, there is no charge. And many metals like copper, aluminium, silver are the good conductors of electricity. That's why while we are making any parts of any appliances, it will be made of metals. So types of conductor. So conductors are the first one is the metal conductor. What is metal conductor? Aluminium, copper, silver. These are the metal conductor. Non-metal conductor. Non-metal conductor is nothing but the some compounds which will behave like the non-metal conductors. And these are known as the ionic conductor like NaCl, HCl, H2SO4. So these are the ionic conductor. And while we are giving some current, it will be divided into the positive and negative, and then it will help to flow the current. Non-metal conductor means some gases will behave to flow of the current like bromium. And semiconductor. Semiconductor is like germanium, phosphorus, whose covalence is 5. 5 means it has a extra free electron in it. So these are the different types of conductors: metal, non-metal, ionic and semiconductors. So these type of conductors can be used for the different types of work. And this ionic conductors is basically used for the electrical heating system or welding system. Next, we will discuss about the superconductor. What is superconductor? The superconductor is a material that offers no resistance to flow of electrons and conducts the electricity. Though we know the conductors have the property to flow the electrons, but the superconductors has no resistance mathematically or a very less amount of the very less amount of the resistance. It offers no resistance of the flow of electrons and conduct electricity. The superconductivity phenomena was first discovered by the Higgs, the Dutch physicist, in the 1951. Superconductors are element of metallic alloy. So it is not the normal metal, it is the metallic alloy. When cooled below a threshold temperature, it loses the electrical resistance property and becomes superconductors. So superconductors are some special elements, a special metallic alloy, and not in the normal temperature. If we cooled down it, we cooled it under some threshold temperature, it loses the normal resistance property and became the superconductors. And what are the some superconductors? As I told, this is the metallic alloy. So this are the niobium, cuprate, magnesium, and diboride. So these are some important superconductors which are used for the as the superconductor. So superconductor main property is it has no resistance to flow the electrons. And what is the and another thing? It is a metallic alloy. It is a metallic alloy and it behaves like a superconductor when it is cooled down under a certain threshold temperature. So what is the behavior of the conductor in an electrical field? Conductors have electrons which are not bound tightly in the atoms. So why conductors? Conductors have some free electrons which are not bound tightly in their atoms. So these are the free to move electrons are there. However, there is no net transfer of electrons from one part of the conductor to the another part in the absence of the electric field. If there is no electric field, there is no movement of the free electrons. But if we give some power or give some potential to it, the free electrons will move from one place to another place. In solid conductors, the free charges move randomly in all directions due to the thermal agitation. While we are giving any electrical field, there is some I square R loss, and due to this thermal agitation, the free charges will move randomly and their net effect becomes zero. So there will be no current inside the conductor. But when the electric field is applied, the general tendency of the electrons is to move in the opposite direction of the electric field and it will constitute and the current. Next important topic is the electrostatic shielding. So electrostatic shielding we get in to protect the certain region of the space from the external electric field, like some costly microscope, or we can tell that some instrument which is used for the space research. So we want to protect them from the external electric field. If any electric charge is nearby, there should be some electric field. So to protect them from the electric field, what we do to protect this delicate instrument from the external electric field, they are enclosed in a hollow conductor, and this is known as the electrostatic shielding. Define dielectric material. So opposite to the electrical conductor, there is another term, that is the dielectric material. What is dielectric material? A dielectric material is defined as a non-metallic material. So unlike the conductor, this is a non-metallic material with specific resistance high. Its specific resistance is high. Temperature coefficient of the resistance is negative. So with the increase of the temperature, the resistance become less, and with large insulation resistance, it will not allow to flow any type of electrons. The another way we can tell dielectric material is a non-conducting material which stores the electrical charges or electrical energy. When a dielectric is placed in the electric field, the electric charges do not flow through the material. So this is called the that's why for the making any capacitor, we keep some dielectric between the two electric plates. Electric charges slightly shifts from their average equilibrium position, causing the dielectric polarization. But the charge has the inherent property that the positive charge will always attract the negative charge. So what they do, they will change slightly from their average equilibrium position so that they can attract each other, and that's why the dielectric polarization occurs if there is any dielectric material between two conductors. Dielectric polarization causes positive charges to flow in the direction of the field and negative charges to shift in the opposite direction of the field. The phenomenon yields an internal electric field which reduces the overall electric field within the electric material. So this is the general property of the dielectric polarization. Electric susceptibility gives the measure of how easily a dielectric material can be polarized when placed in an electric field. Generally, electric field the dielectric constant cannot be broke. So, susceptibility means how easily a dielectric material can be polarized, how it can be changes its shape. What are the properties of the dielectric material? The properties of the dielectric material is first, the energy gap of the dielectric material is very large. It takes more energy to to take one free electrons. The electrons are tightly bound. It needs more energy to create one free electron. The temperature of the resistance is negative. If we increase the temperature after a certain value, at a breakdown voltage or at a breakdown temperature, there will be some free electrons. So the temperature coefficient of the resistance is negative. If we increase the temperature, the resistance will decrease. But the insulation resistance is high. In the normal condition, it will never allow any free electrons to move. So it has some insulation resistance. That's why we can tell dielectric have a high resistivity. High resistivity means naturally in the normal temperature, its insulation resistivity is very high. The attraction between the electrons and parent nucleus is very strong. The electrical conductivity of this material is very low as there are no free electrons to carry the current. So as electrical conductivity is very low as there is no free electrons in the case of the dielectric. What are the application of the dielectric? Dielectric are used as the capacitors for storing energy. This is the main application of the dielectric. The dielectric material is used in the transformer as an insulator and a cooling agent, like transformer, oil, air. They are behaves for the insulator between the coils, and it will behave like the cooling agent. To enhance the performance of the semiconductor drives, high permittivity dielectric materials are used. This is used for the electronics equipment. The electrodes is processed dielectric material that acts as an electrostatic equivalent to the magnet. So what is the property of the electric field inside the dielectric? When an external electric field is applied on a dielectric, the charges aligned in such a way that an internal electric field is produced. The magnitude of the electric field is smaller than the external electric field, and this is only due to the polarization of the dielectric. Therefore, the net electric field inside the dielectric is not zero. And what will happen? If out external is E and internal is EI, the overall intensity is not zero. The electric field has some value as electrical external is greater than the field internal, and the direction of the field will be parallel to the external electrical field. The external electrical field applied to the dielectric material and the material becomes polarized, which means that acquires a dipole moment, and this property of the dielectric is known as the polarizability. So, what are the difference between the conductors and dielectric? The difference between the conductors and dielectrics are electrons are lies inside, but in the conductor electrons are on the surface. Free electrons are not there in the case of the dielectric. Free electrons are there in the case of the conductor. Energy is stored, energy is dissipated. What is the difference between the dielectric and insulator? The dielectric materials that can develop an electric field with the minimal loss known as the dielectric. Insulator is the low conductivity that will obstruct the flow of current is known as the insulator. Weakly bonded, this is the covalently bonded. It can store charge, it can obstruct the charge. Their application in the power cables and capacitor, they are for the high voltage system. So the application of the dielectric of the capacitance. What is the capacitance? The capacitance of the capacitor is defined as the charge Q developed between the plates when the V is applied. So we know that if C is equal to Q by V, if there are two parallel plates and if we connect it with the charge, if there is some dielectric material, so C is equal to Q by V. C is equal to Q by V. The unit of the capacitance are farads. So this is the example of the dielectric. And the capacitance of the parallel plate is epsilon A by D, or epsilon is dielectric. What is D? D is the distance between them, and what is A? A is the cross-sectional area of the plates. Already we have discussed in details in the last class. So I am not discussing it again. And this is the thank you. So what we have discussed today? We have discussed the polarization, dipole moment, torque of a dipole moment. Then we have discussed about the conductor, properties of the conductor, what is superconductor, dielectric, properties of the dielectric, and what the application of the dielectrics, the field behavior inside a conductor, field behavior inside a dielectric. Then we have discussed about the difference between the dielectric and field and dielectric and insulator, and application of the dielectric is the capacitor. So this is up to today's class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.